Hello, in this video I will talk about friction and friction on an inclined plane. Now, friction is the force resisting relative motion of surfaces sliding against each other. Friction is a force that opposes motion. What we are seeing on these two diagrams are the different types of forces, which is a pulling and a pushing force. In this case, we can see, in both cases, we can see that a frictional force always opposes motion in both cases. So in a nutshell, a frictional force is a force that opposes motion. Right here, we'll take a look at the two types of frictional force. One is called dynamic friction. This friction is also called sliding friction. It's a friction that occurs when motion is taking place. Okay, while static friction is the friction that occurs before motion takes place. All right, it's a friction that occurs before motion takes place. Static friction resists motion, while dynamic friction resists sliding. So please take note of these two terms. Now we'll look at three factors that can affect the size and direction of frictional force. The first is that the size of a frictional force depends on the type of surface. Number one, the size of frictional force depends on the type of surface. That's the first factor. The number two, the size of frictional force depends on the size of the force acting at right angle to the surface. All right, and that force is called the normal force. In our previous videos, I showed us how a normal force acts on a surface. It's a force that always acts upwards. It acts perpendicular to the surface. That is called a normal force. And the last factor that affects frictional force is that, number three, the direction of the frictional force is always opposite to the direction of motion. The direction of the frictional force is always opposite to the direction of motion. All right, so these are the three factors that affect the size and direction of frictional force. The first is the type of surface. The second is the force acting at right angle to the surface, which is called the normal force. And third is the direction of the frictional force is always opposite to the direction of motion. Now we'll look at the coefficient of friction. The symbol we use for this is written as this. This is the symbol we use for coefficient of friction. It's a measure of the amount of friction existing between two surfaces. It's a measure of the amount of friction existing between two surfaces. Now, it is a ratio of the frictional force, F, over the normal force. Here is an equation for coefficient of friction. It is the ratio of the frictional force F The F is your frictional force. While the N is our normal force. Okay, so this is a very important formula that we have to note. Now we can transpose this formula to make the frictional force the subject. So we can transpose, so we can make our F the subject of formula by cross multiplying. So we have F equal to rho times N. So here is the formula for finding frictional force. All right, let's look at an example. All right, so right here is an example. It says a block of steel requires a force of 12.5 Newton applied parallel to a steel plate to keep it moving with constant velocity across the plate. If the normal force between the block and the plate is 50 Newton, we're asked to calculate the dynamic coefficient of friction. So the first thing I do first is to write out my given data. I'm given the force, which is F, that is 12.5 Newton. Okay, now I'm given the normal force, which is N, is giving us 50 Newton. So question now, we're asked to find the dynamic coefficient of friction, which is rho subscript D. It's giving us rho subscript D. Okay, now we can solve this using the formula. We know that the formula for friction is rho subscript D is equal to the frictional force F over the normal force. So what next? I can log in the details. That becomes my F is 12.5, my N is 50. So therefore my dynamic frictional force becomes, so 12.5 divided by 50 will give us 0.25. So my dynamic coefficient of friction is 0.25. Please remember that it has no units because it is a ratio of two forces. Please note this, please. Note that coefficient of friction has no units because it is a ratio of two forces. So it has no units. All right. All right. That is very, very important. And please, we have to note that. All right. So here is a practice question which I want you to do, and you are free to send me your answers to my email. All right. So now we'll look at friction in an inclined plane. Friction in an inclined plane. Now, as you can see on this plane, you have P is your applied force, okay, while F is the frictional force, N is the normal force which is acting on the surface, and right here is a next force that is inclined. All right. Now, if you remember in our previous videos and classes, we are told that when a force is inclined, that means that we can resolve that force into vertical and horizontal components using the trig ratios. So please note again that, as you can see right here, This is an object that is being moved up. Motion, that means it's being moved up. So here is my applied force. And as always, F here is the frictional force that is trying to oppose the motion. If you don't mind, I can label it. Here is the applied force, P, and right here is the frictional force, F. Good. In fact, in this case, we have 3 forces or 4 forces. We have the applied force, we have the frictional force, then we have an inclined force, mg. Okay, and we have the normal force acting up. Now, this force is inclined, so we have to resolve this force before we can solve this question, before we can attempt this question. So I will have to draw a sketch and see how I can resolve this figure. Now I'm given this. Okay, yes, my angle. This is called the angle of repose. This is theta. It is called the angle of repose. Now here is the object going up. As you can see, it's going up. All right. This motion tells us the direction of the object. Okay. Now right here I have my applied force P. Okay. All right, and right here I have my frictional force F. If you don't mind, right here I have my N, which is acting up. I can put it right here. That's my N. Please note that your normal force always acts upwards. Okay. So also I have a force that is inclined. Right here, look at this force. It's inclined, and this is my mg. Okay. This is my mg. All right. So the first thing I do is to resolve this mg because it's inclined. So that means I will have a vertical force going down. Look at this very well. And also I will have what? Force going horizontal. Good. Now here is the angle. And please note that this angle is the same as this angle. They are equal. I have to find the value for these components and the value for these components, because now I'm trying to resolve my mg into a vertical and what? An horizontal component. So to do that, I'll call this my horizontal and call it H. I'll call this my vertical V. Okay. Now to get my H, I have to use the trig ratios, which is I have to use sine. All right. So if I use sine theta equal to, sine is opposite, which is H is opposite, over hypotenuse, which is mg. As you can see, here's your opposite, here's your hypotenuse, and right here is your adjacent. So for sine to be the opposite, which is H, over the hypotenuse, which is mg. Good. So I can make H the subject. So we now have what? H is equal to mg sine theta. So therefore, my value for my component at this point is mg sine theta. Please remember that our G is always 9.81. Our G is 9.81 meters per second squared. So please, when solving questions, you must use your G as 9.81 meters per second. So I've gotten my component for the horizontal. Now I have to find the component for the vertical. So for the vertical, to find my V, I have to use cos. So I can say cos theta will be equal to, cos is adjacent, which is in this case is V, is my V is adjacent over hypotenuse, so which is my mg. This is my hypotenuse, which is my mg. So therefore I want to make my V the subject, so I will cross multiply. So therefore my vertical component V is equal to mg cos theta. All right, so this is for my mg. So my mg is equal to what? So my V is equal to mg cos theta. Mg cos theta. All right. Now I can now solve this question. The first thing you do, please remember, if your force is inclined, you have to resolve that force into a vertical and what? Horizontal component. Then you can now solve this question. Now we have two concepts here, and please don't forget that our F is always equal to what? The constant times the normal force. In most questions, you'll be given this value for the coefficient of friction. Is always given. Now to solve this question, you can see that I have forces going up, going to my right and to my left, and I have forces going up and going down. Now I can say that the forces going to my right, which is P and F, are parallel to the plane. As you can see, forces P and F, and even our H, as you can see right here, I have this and this, they are what? Parallel to the plane. While forces V, which is mg cos theta, and N are perpendicular to the plane. So we have to resolve forces parallel to the plane and forces perpendicular to the plane. So the first thing we do is right here is to resolve forces parallel to the plane. All right, look at this. Forces P, F, and H are parallel to the plane. Okay, so that means I can say that the sum of the forces moving to my right is equal to the sum of the forces moving to my left. Please, the first thing we do here is that we have to resolve the parallel forces. And as you can see from the question, forces P, forces F, and now force H are parallel to the plane. P is going to your right, and F and H are going to our left. So that means I can say the forces to my left, which is, sorry, to my right, which is P, so it's P equal to the forces to my left, which is F plus my H. And what is my H? It's mg sine theta plus mg sine theta. With this, we can solve for the value for our P, which is the applied force. Now, the next thing we do again is to resolve forces that is perpendicular to the plane. Step 2, we resolve forces perpendicular to the plane. As you can see right on your screen, force N and V are perpendicular to the plane. So we will have to resolve, we have to find a formula for this. So force N and V are perpendicular to the plane. So I can say therefore the sum of forces going up is equal to the sum of forces going down. All right, so therefore the forces going up is my N, as you can see right here, is perpendicular, it's my N, so it's my N, which is equal to the forces going down is my V, and my V is mg cos theta, so N equal to mg cos theta. So these are the different ways we can solve friction in an inclined plane. What I'm saying right here is that step 1, we have to resolve any inclined force into vertical and horizontal components. Then the second step is to resolve forces that are parallel to the plane, and 2, to resolve forces that are perpendicular to the plane. With this, you don't have to remember any formula. Just have to remember these 3 concepts. Number 1, you resolve the inclined force into vertical and what? Horizontal component. Step 2, you resolve the forces that are parallel to the plane. And step 3, you resolve the forces that are perpendicular to the plane. I will show us an example of how we can apply these concepts in solving a question. All right, let's look at a question. It says, for a mass of 30 kg, as you can see right here, this is the mass, just moving down. Now, this motion right here, the direction of your motion tells you the direction of the object. And it tells us that P is the applied force because the object is going down an inclined plane, and as always there's a frictional force F acting opposite to the applied force. And right here again is a force that is inclined to the plane, and also right here is our normal force. We always have a normal force acting on the surface. Now the first thing I do is to draw this diagram so I can resolve my mg. So I will draw diagram again. Here's my theta. Right here is the body. Okay. Here is my applied force P, and right here is the frictional force F. Okay, and as you can see right here is my normal force N is acting on the surface, and also right here is the force inclined at mg. Okay, here is my inclined force mg. All right, so because it's inclined, I have to resolve it into 2 components. Don't forget that, please. Yes, my V vertical, and I resolve it to the horizontal. Very important. Here's my horizontal. And don't forget that this angle is theta, is the same as the angle given. My angle is 20. My constant for friction is 0.4, and the mass is 30 kg. Please remember that your mg, your g is equal to 9.81. G is always equal to 9.81 meters per second squared. All right, so the first thing we do right here is to find the value for V and H. Now, it is always very important to double check if your H and V are what we think it is, because sometimes the values for V and H might change depending on the position of the inclined force. So please always check for the value for H and V. So, all right, so for my V, I can check for it. So this is the angle, so my V, this is the opposite. All right, here is my adjacent, and this is my hypotenuse. To get my H, I have to use sine to become sine theta is equal to opposite, which is H, over mg, which is the hypotenuse. So I can transpose to get my H. So my H is equal to mg sine theta okay. So my H is mg sine theta. So my H is equal to mg sine theta. All right. Next, I check for my V. For the V, my V is the adjacent. To get my adjacent, I have to use my cos. I use cos theta is equal to adjacent, which is the V, is my adjacent, V, over the hypotenuse, which is my mg. So my V therefore is mg cos theta. All right, so my V is mg cos theta. Good. So please, it is very important to check the correct values for your V and H. Most times, if your inclined angle is at this position, you are likely to get your H as mg sin theta and V as mg cos theta. But if your inclined angle changes position, you have to double check to ensure that you are using the right equation. Now, I have my frictional force, my applied force, I have my normal force, I have my H right here, and my V. Now, as you can see, my N and V are perpendicular. My F, P, and my H are acting parallel to the plane. So I have to resolve the forces going perpendicular and resolve the forces going parallel. So I will start with the first step. Now I can say, okay, let's resolve forces acting perpendicular to the plane. All right, that means we are saying that the sum of the forces acting upwards is equal to the sum of the forces going down. As you can see right here, I have my N going up, I have my V going down. Look at it, my N going up, V going down. So it becomes forces going up is my N is equal to the forces going down is my V, and my V is what? Mg cos theta. So it's Mg cos theta. All right, so right here I can log in the values. My M is 30, the mass is 30 times my G is 9.81 cos my angle is 20 cos 20. So guys, when you log this into your calculator, your N should be 276.55. So my N, which is the normal force, is 276.55 Newton. So that is the value for my normal force, which is acting upwards. So the next thing we do is to find the forces acting parallel to the plane. So we can reserve the forces acting parallel to the plane. Now to do this, we sum the forces to the right must be equal to the sum of the forces to the left. That is, the force to the right is my F, and the forces to the left is my P and my H. You can see they are going to the left, so it will be forces to the right, which is F equal to my P plus the H, which is mg sine theta. Mg sine theta. Now, from the question, we are asked to find the value for P. So P is not known. I can find the value for F by using the formula, which is F is equal to the constant rho times my N. I hope we all remember this formula. Okay. Now, to get my P, I can transpose this formula. So therefore, I will move my plus mg sine theta to my left, becomes a minus. So therefore, my P is equal to F minus mg sine theta. All right. Okay. So let's move this to the next slide. Okay. So our P is equal to F minus mg sine theta. And guys, please remember that my F is equal to the constant times my normal force. All right, so I can log this into the equation. So therefore, I can say my P, which is the applied force, is equal to my F is rho times N minus mg sine theta. So we can now log in the data. P equal to the value for my rho is what? It is giving us 0.4. So 0.4 times our N is what? Our N is 276.55. 276.55 minus my M is 30. My G is 9.81. Sine 20. All right, so therefore 0.4 times 276.55 will give us 110.62 minus 30 times 9.81 sine 20 will give us 100.66. Okay, so our final answer is 9.96 Newton. So I hope you understood this concept. All right, so here is a practice question for you to apply all you have learned so far in this video. If you have a question or a comment, you're free to send me an email or leave the comment in the comment section below.